All right, so this is a section that is not in the chapter 10. We're kind of taking off on a different, not a different tangent. It fits in this section. So this is called higher order derivatives. So what I'm going to show you first is this is just an introduction. So higher order derivatives is when we're finding derivatives of derivatives. So up until this point, we've only been doing first derivative functions. And so marginal cost is a first derivative cost. So again, a derivative is just the slope. It means that we have a rate of change that's either increasing or decreasing. So when we work with higher order derivatives, there's another application that comes into the process. So when you take the slope of a slope or the derivative of a derivative, what you end up with is what's called concavity. So when you look at that, here are 4 different scenarios. So when we look at this, if I look at the slope, just first derivative, the slope, you can see that my slope based on this pen is increasing the whole time. So we have our first derivative is increasing. That means it's greater than 0. It's a positive slope. Well, what happens is when my first derivative here, it's increasing very quickly. You can see the steepness of the slope. Then as I move along this function, the slope starts slowing down. So here my rate of change is very steep. And then as I move along this function, my slope gets less and less steep, so the pitch changes. Now, the difference between here, I have a very steep slope, and here I have a very shallow slope, or it's just barely rising. It's still rising, but it's just barely rising. So what this indicates is what's called a second derivative is decreasing. So we have an increasing first derivative and a decreasing second derivative. What that indicates, and notice when I did second derivative, I do 2 tick marks. First derivative is 1, second derivative is 2 tick marks. What happens is the shape of my function, it has a downward shape, or the concavity goes down. So that means the curvature of the function is going down. What this means is I have an increasing slope, but my increasing slope is actually decreasing. So we have a first derivative that's increasing, a second derivative that's decreasing. That means that the measure is increasing at a slower pace. Okay, because my slope is slowing down. So that indicates the concavity, okay? Over here, on my second example, if you notice, my slope is not very steep here, but as I move along, my slope gets steeper and steeper and steeper and steeper. So with this one, my first derivative is still increasing, right? It's still greater than 0. I still have an increasing slope. But if you notice the difference between this one, the first one, and the second one, this one, the concavity is down. This one, the concavity goes up. So that means it's opening up. So with this one, my second derivative is increasing because I have the slope is speeding up, right? The derivative is speeding up. And so I have a increasing second derivative. So what this indicates is I have a function that it's increasing, but it's increasing at a slower pace. And then as I move along, my slope increases. So my rate is increasing. The rate of the slope is increasing. Okay, so that's the rate of a rate, or the derivative of a derivative. Okay, so this one, the concavity is up. Okay, here concavity is down because I have a decreasing second derivative. Here the concavity is up because I have an increasing second derivative. All right, so example 3 looks a little different. So what kind of slope am I showing? So first derivative, what kind of slope is this? So you can see it's kind of slow starting out, and then my slope gets steeper and steeper and steeper. But if you notice, here my slope is going downhill. Here my slope is going uphill. So now with this one, my first derivative is decreasing. So it's a negative slope. So remember, negative slope, you have a slope that goes downhill. Positive slope, you have a slope that goes uphill. So what this indicates is I have the value is, or the slope is less than 0. That means it's a decreasing slope. It means it's a negative value. Okay, so again, going along, here's my slope. The slope continues and it starts increasing, right? So the slope is getting steeper and steeper and steeper. So in this case, I have a second derivative that is also decreasing faster. So it is less than 0. Okay, so I have a first derivative that's negative, and I have a second derivative that's also negative. So again, our concavity on our second function is going down. It opens down. Okay, and then our last example, again, here's I'm looking at the slope. So my first derivative is still negative. So my first derivative is still negative. It's still going down, or it's decreasing in value. But if you notice, it's decreasing at a slower rate. Here, it's decreasing at a faster rate. Here, it's quick now, but then it slows down. So when you have a second derivative that slows down, it's decreasing at a slower rate, then I have a second derivative that's positive. So here's some examples. If you have, let me just give you some examples of where this would come into play. So we have the number of unemployed people is declining, but more slowly. So we have a declining number of unemployed people, but it's slowing down, okay? So it's declining, right? But in this case, it's speeding up. Here, it's declining, but it's slowing down. So this one is, we have a negative first derivative and a positive second derivative, okay? Here's another example. The temperature is dropping faster than it did yesterday. So it's dropping, right? It's dropping, so it's a negative first derivative, but it's dropping faster, so the decrease is speeding up, so that means I have a negative second derivative. Another example, the population is growing increasingly fast. So growing means a positive, okay? It's growing, but in this case, it's growing and the growth slows down. Here, it's growing and the growth speeds up. So this one is, we have a positive first derivative and a positive second derivative. And then the last one, the economy is growing, but more slowly. So we have a growing economy. It's growing, but the growth is slowing down. Okay, so I have strong economy growing, but then the growth slows down. So I have a positive first derivative and a negative second derivative. So second derivative, the premise is it's either concave up, okay, concave up, or it's concave down. It is speeding up or it's slowing down, okay? This one is slowing down and this one is slowing down. So it depends on what your second derivative is doing will determine if something is speeding up or slowing down. That's the introduction. Now I'm going to show you how to actually find higher order derivatives.